Thank you, everyone, for joining us today for part 3 of our series on AI and all things data engineering and detection engineering and security. So, what do you do? We talked about in our very first one, we talked about just how do you start implementing AI or leveraging AI for your security program. In the second part, it's how do you use that AI that you've implemented or that you're leveraging for automations and to make sure you're tuning and updating things and doing things at a machine speed, at a business speed that maybe that humans can't live up to and get done at the time we need it to, or can't compute everything that's happening, but computers can, right? So how are you tuning, maintaining, and keeping up your environment leveraging AI? And now in part 3, and probably one of the most important things because it's maybe one of the most annoying things to go back and continually do. And it's somewhere where, and Mike and Scott can jump in here and correct me, but I feel like it's one of those areas that gets missed a little bit because it's just something that you need to get done and you need to do, but it falls to the bottom of priority lists or your backlog and you get it done half-assed maybe. And so, correct, do you guys feel the same way about that?
Oh, absolutely.
Yeah, I
Awesome. So,
agree. I mean, usually that might be one of the last things on your checklist as you're standing everything up.
yeah, so as something that is so important, and before we jump into this, and I know we're going to get into it, but I guess we're going to talk about why is this so important, why it shouldn't be something that we're going to be missing doing, and how you can make sure that you can leverage AI so it is something you're doing in a timely manner, and not just a timely manner, but you're getting it done to the extent that will actually benefit you rather than just something you have to get done as a checklist. I'm joined, if you haven't joined part 1 or part 2, definitely go check those out on YouTube. If you have questions, please put those in the chat below. But for Mike and Scott, I'm going to hand it over to you. My name is Jade Catalano, so thank you guys all for joining. I've been at Anvilogic 3 years now. I was at Splunk prior to that for about 10 years and in the security industry, probably 15 to 20 now. I know I'm getting old. And this is where my favorite place is to talk about, right? Is not just security, but how we're morphing security to do it better and bringing it into where we are today and building it so we can use it tomorrow. It sounds very markety, so I'm gonna hand it over to our resident data scientist team and Mike and Scott, if you want to introduce yourselves.
All right, thanks. Yeah, so Scott Rodgers, based out of Charlotte, North Carolina, and principal data scientist here at Anvilogic, and spent a lot of time in the area between data science and cybersecurity, merging those two fields together.
Excellent. It's Mike Hart and Jade. Like you, I've been around the block a few times. So I'm based out of Hartford. I'm a principal data scientist here at Anvilogic. I was also at Semantic Research Labs, doing things with data loss prevention, data governance. Also, moonlighted as a software engineer at Google and did my PhD in computer science, looking at the intersection of AI and computer security.
So guys, before we jump in, just because we have the time and I would like to ask these questions, before we get into the health monitoring, I'd love to hear from each of you on your take on where this convergence is happening between AI and security, because you both come from this background. It's not a typical background. I know it's happening more and more often for data scientists and security to do a crossover and find data scientists that are starting to understand security. But I also love the background of knowing security first and then bringing in data science. So I guess, where do you see that convergence happening first? And maybe what do people need to start thinking about when we're thinking about AI in the context of all of this and what we're going to be talking about today?
Yeah, I can start on that one. So one of the things I think about a lot is, you have data science, which is kind of a subset of skills. You have cybersecurity, security, its own subset of skills. But from a data science perspective, you could look at cybersecurity data as just a domain that you're practicing data science on. So that's, one of the things I would say. But security has a lot of data, a lot of logs, more than one person can look at and keep up with, and that's really why I think you're seeing such a convergence between the two domains.
Oh, absolutely. To kind of piggyback on that, I mean, for me, I think the sweet spot, the dream really is that there are a lot of logs that you're going to receive, right? Coming from these voluminous data sources, be it your endpoint, your cloud, right? Your proxy, what have you. And really, I mean, if you can outsource to AI, sort of the triage, remediation of some of these really just basic things that happen all the time, right? And really, the more difficult, the more novel problems are the things that you spend your time focusing on, is really sort of like a great partnership that could happen, particularly in cybersecurity, where, novel attacks can be very difficult for AI to sort of reason about in a logical way. But that's where, as humans, right, we have that creativity, we have that intuition to really, look at a novel or this new situation you've never seen before and maybe piece it together. So I think that's where I'm hoping the convergence goes, where really the machine can scale you out and take care of a lot of the boring, mundane things. And you really focus your time on doing the more interesting, insightful things that really, require that creativity and experience that only you as the analyst brings to the job.
That makes total sense. And I think that leads us perfectly into health monitoring, the thing that just falls to the bottom that no one really wants to do, but knows you have to do. So why is this important? Why is this on the checklist? Why do you have to do it if it keeps falling to the bottom? And how can we start to improve that?
Yeah, it's super important. And I would say it's not just important, it's critical. It's really critical to the success of your operation. And I mean, think about it. If you have, every tool in the world, you have every tool in the world deployed, but it's not actually working, not running, not enabled. What's it doing? You can't do anything without that. So yeah, I would say it's super important. And then to get into a little bit about what it is, the goal of health monitoring is really to ensure that you have visibility and observability of your environment. And that means all of your hosts, you have logs coming in, all of your clouds, maybe you have one cloud, maybe you have multiple cloud providers. You have logs and observability into all those clouds. And you could even go as far as saying your SaaS application. So do you have observability into those? Do you know if a lot of data is leaving via one of your SaaS applications, for example? So that's a little bit about why I think it's important. Yeah.
Yeah. And so if it's this important, it's always been this important. Why would we even need to be talking about it today? Like, wouldn't we just think that everyone's doing this? Like, why aren't people being able to being successful at health monitoring?
Yeah, I mean, we have a lot of challenges and we'll talk about that coming up, some of the challenges, but there's a lot of challenges to staying on top of health monitoring, similar to if you heard in our last detection dispatch on detection engineering being an ongoing process, the constant need to tune and curate your detections. It's really the same of health monitoring. Maybe you did do it on your checklist a while back, you set it up and it was good, and now your environment's evolved, it's changed, you've brought on new tools, new acquisitions, and now your health monitoring is no longer effective.
Oh, precisely. Like, let's just say kind of maybe a good recent example is like the Move It vulnerability, right? So you hear about it, well, you got to move on that quick, right? And you need to have content, you need to deploy things to make sure that that particular vulnerability doesn't affect you in an adverse way. And that's going to take 110% of your focus, right? So the things that you should be doing, right? Tuning your content, making sure that your queries run, just unfortunately kind of slide right down the priority, stack, right? Because really, when you hear about something that really motivates you, that you need to build content for, make sure that you have, a good grip on if you're protected from a particular vulnerability, right? That's where health monitoring and things like that can kind of get pushed to the side, and where your people are just really focused on, what is that critical P1 kind of thing that's happening right now.
So if I could kind of summarize this as we move on to the next things that we were talking about with health monitoring, I'm thinking of an analogy, and I might be way off. Sometimes I throw out analogies and they go sideways, but security is usually thought of or talked about in an analogy of a house. And you have your doors and your windows and you're protecting the house, and then you have everything around it and you have your fire alarms and you have everything, right? And I'm almost kind of thinking of health monitoring as keeping up your house, like the roof, for example. And typically, sure, your roof is there, sure, you see it. You're aware that it's fine, it's above you, but when all of a sudden there's a rainstorm and you get a leak, then everything goes to fixing that leak. And then are you are you monitoring the rest of what's happening in your house? Is there a leak on the windows? Is there a leak other places? So that's a lot of different, then you're running around putting buckets everywhere around the house instead of one being preemptive and knowing this before the rainy season, and you're going to check all the seals, or during it you're aware that, okay, there's one leak in the roof. Now I know that I'm already monitoring all of the sealing that's happening, so then we're being able to keep that up and not have to run around with buckets and scramble.
For sure, yeah. Or even better, maybe you have some kind of setup where you get a notification that the quality of your roof is declining. Like or you just kind of maybe intuitively, it's like getting 20 years old or something. But in a security context, maybe that the quality of your environment is degrading, like the capacity's hitting its max. But
Right.
yeah.
And I think that's where people have been sitting for a long time, is they come in once a year and do a big check, or they have parameters once a quarter, but it's not enough. And they're going to be missing things because there is so much voluminous data and there is so many different platforms and everything. So I know you're going to get into a little bit more of how to start implementing and talking about health monitoring with AI. So I'm going to let you guys kick off with that.
Yeah. Yeah. So before we get into the how, I want to add a little foundational context, and something I think that's pretty important to explain and helps lead into how things are designed and why it's important is the CIA triad. And CIA, as you can see, as confidentiality, availability, and integrity. And this triad really highlights the fact that there's every system you design, every problem you face, often will involve trade-offs between these three components. So from confidentiality, that's the need to protect sensitive information. Say maybe you're protecting healthcare information, that would need to be kept sensitively protected, shouldn't be shared with unauthorized parties. Integrity, the need for data to be authentic and correct and reliable. Again, with the healthcare example, you wouldn't want your healthcare data to be altered or deleted. And availability. Last, you need to have that your networks up and running, data accessible. With the healthcare example, a doctor might need to access your healthcare data. He needs to be able to do that in a timely manner. And one way to highlight the trade-offs, and we'll focus on confidentiality versus availability. Say we want to make sure our healthcare data is perfectly protected. No one will ever steal it. So we print it out on a piece of paper, put it in a vault, lock the vault door, delete it from our computers, and no one's ever going to hack in and steal that information. Assuming the vault bank stays pretty secure. But the flip side is then we now have no availability. The doctor wants to access that information, he'd need to go into that vault or the bank and find that piece of paper with the information on it, which isn't very practical. And that kind of highlights how there's a trade-off that has to be made to make systems work. And one of the lesser known kind of opposition to CIA triad is the DAD triad, which is destruction, alteration, and disclosure. And those are really the opposites of the CIA. So we'll just talk about alteration. As I mentioned in the healthcare example, alteration would be changing the healthcare data to make it inaccurate or even maybe dangerous. But how does this relate to health monitoring? Well, we'll talk a little bit more on the next slide, but health monitoring, I think two key pillars of it really rely on integrity and availability. So Mike, what are some questions we might ask or things we might think about on comparing integrity to health monitoring?
I think the big thing, the question is like integrity, particularly for like if I'm your CISO, right? I want to make sure that that content has run in a timely fashion, on the right logs, right? And that we're really, keeping up to date. Because like when I think about any kind of analytic that I run, be it, a signature or some ML model, right? To know that this thing is running, really like that integrity of it is that it's being run on, the right cadence, on the right logs, at the right time, and that if, results get put correctly in the right spot, and that if there is an issue, that issue comes to light as quickly as possible.
Awesome. Yeah, so these really lead into our some of the challenges that we'll talk about. But the next kind of pillar, building on the CIA triad, I think you can get to observability. So you need a combination of availability and integrity to reach observability. And observability is really being able to understand the current state of a system from its external output. So an analogy here, imagine you have a tree that's growing. Imagine you can just cut the tree open and look at all the rings and see, everything that can be determined from the rings. So you can look at the rings and determine the age of the tree, how well it's survived some of the past, weather events, or the general health of the tree. And we're trying to do that without being, without cutting open the tree. And that's really observability, is having the insight into what's going on in that tree without actually being able to cut it open and do that. But yeah, depending on who you ask, there's some, I guess, the verdict's out on how many pillars of observability there is. There's still some theoretical differences, but somewhere between 3 and 6. And another acronym that typically goes along with this is MELT: metrics, events, logs, and traces. For our purposes, I'm going to scratch out events, and we're just going to talk about metrics, logs, and traces, which is the 3 pillars that some people use. So for a metric, you can think of this as something that's numerical, it's high level, represents data. Great example of this is CPU utilization or percentage of disk space available. Things like that are a metric that help you understand the situation. Is your AWS resource underutilized, the CPU is barely running, or is it topping out and you need to expand your resources, allocate more resources? You can learn that by looking at metrics. And if you were to look at something like logs, it's not as easy necessarily to determine those kind of come to those conclusions. So if we talk about logs next, logs are discrete occurrences of something, maybe an event, usually have time associated with them, precise values. And an example of that might be a user failing to log into a computer. So then they do that, a log is generated, and then someone can look at that log and see, hey, at this time, Scott failed to log into his computer. Maybe he failed 5 times and there's 5 logs. So they're really a key for understanding what's going on in the system without being able to cut open that tree and actually see.
And in theory, this all sounds normal and typical, and this is how I think most of us probably think of the world. But I feel like we're still in having the same challenges that we've already had. And I know you're going to get into some of these challenges that comes along with all of this, but I'd love to hear too, when you get into those challenges, why are we still having these same challenges? And then we can get into how we can tackle it or what we can do about it. But I just think it sounds good in theory, but like when we start putting it in practice, that's when things break down. So what are some of these challenges that you're going to go into, and how can we, and we'll get into how we can start addressing, but what are the challenges, and really why are these still happening? Why haven't we been able to solve this?
Yeah, for sure. For sure. Yeah, we'll get into some challenges, and one off the bat is just the changing landscape, as we've kind of talked about, but I think that's one of the keys. But yeah, so traces is the last of the 3 pillars, and it's looking at the behavior of something end to end in a system, so that maybe the behavior of a request end to end going through a system. And a great example of this is a stack trace in programming. And if you're not familiar with the stack trace, you have part 1 of your code, which called part 2 of your code, and then in a certain line on part 2 of your code, it broke. And that's essentially a stack trace, and you can look at that and understand why there was a problem and how it occurred. But you need all these in combination to achieve observability. And some of the challenges, like you were asking about, one of the hardest ones is it's really hard to prove the negative or the absence of something. And maybe that might strike you as weird, but if you think about it and you have an alert, a very specific alert. Mike mentioned to move it. Maybe you're responding to move it. Well, hopefully you don't see move it in your environment very frequently. But if you did, you might have a lot of alerts from it. But it's hard to know, is your alert working? Is it operating correctly? Or is it just not finding anything? And determining the difference is a pretty hard challenge that faced with health monitoring.
Well, and would you say that this is also a piece of that problem we hear all the time, right? That you have a skills gap, or you're just not sure what's happening in your environment. You don't have that visibility. So determining the negative, being able to prove the negative of something or absence, you also have to know what you're looking for. You have to even know it might exist.
For sure, yeah. And I mean, it's, maybe you go so far as to generate data to see what it might look like, but then maybe when it really happens, it looks different than the data you generated and your alert just doesn't work. So that's all the kinds of things you have to deal with maintaining a healthy security environment.
How often does this happen?
I mean, I would say, I don't know, that's a good question. Mike, you have any thoughts on that one?
It's really hard to say, right? Because if you don't have, like, absolutely you can introduce like a logical error into your queries, right? Or something is not configured that should be sending logs to your event collector that are not. So it probably happens more often than we like. It would be hard to quantify it, but that's the difficulty. And again, why we need to, invest a lot of time thinking about these systems holistically, how we're, collecting the data, how we're looking at the data, how do we act on the data. And then also just getting back to, the brass tacks of saying like, okay, right, is every potential system connected? And Scott had some great examples of like, what, even if you have the system connected, there can also still be lots of problems.
Yeah,
For
I guess
sure.
that's
Yeah,
just
and
where
but
I was just saying, I think this is where maybe those percentages of things that sit in your environment for a certain amount of time or that just go undetected forever and everyone goes back, like, why did we miss this? It was here. We had alerts for it, all of that. But if you're not looking for the exact right thing, you might not get it.
For sure.
Exactly.
Yeah, and that goes into the next one of, there's large volumes of data, a lot of variety of data. So all those things make it more challenging to stay on top of everything. And then combine that with the next bullet, shifting environments. Everything's changing, new vulnerabilities, new tools. And one thing that can frequently result in is parsing issues. So that's saying like, hey, we have a log that was generated. It's an unstructured log. It's just text, maybe with commas separating the fields, and someone, there was an update and a new field was added, and now our parsing is no longer grabbing the right fields and making them usable. It's messed up. So, Mike, what's key fields? What are some key fields in a log that would be really critical if they were messed up?
What are my top three, right? You have to know the user, right? User can give you so much insight into level of concern, right? Is it the system user, privileged user, regular user? Got to know the host, where did it run, right? And then on top of that, having IPs extremely useful, particularly if you can resolve internal IPs to any external IPs in your proxy logs. So definitely having all the IPs that are being registered, that are communicating. And I would say that, yeah, those would probably be, and then obviously you need the time, right? But usually when you see an attack, right, there's definitely certain attacks where making sure that you not only have the time window correlated on user, host, and potentially IP, that can really help, find and elucidate the breadth of the attack, right? But if you don't have the host, the IP, the user correctly parsed, it's gonna be a tough time.
Totally agree. Yeah. Some other problems you can run into with shifting environment, asset inventory getting out of date. So do you know all your assets? Are you on top of it? Somebody brought in a new computer. Are you aware of it? Are your tools deployed on it? Maybe it's running an OS that's incompatible with your security tools. Are you on that? A lot of things. And the last challenge we got here, minimal logging. This one is super important, and that's why we're calling it out here. It's a little different than some of the other challenges. It might be a choice that was made due to other constraints, but minimal logging, and one example of that is not logging command line parameters, is really makes the visibility, your observability, your level of that a lot lower. So imagine on this example we have here process logs. Imagine you see desktop image downloader exe, which is a normal executable that runs on Windows and downloads image desktop images. Imagine you see that run and you have the top log, and versus you see that run and you have the bottom log where you can see they're downloading a known malicious executable. So that's kind of the difference and one of the challenges you can run into depending on your verbosity of logging. Well, so with the challenges addressed, we'll look at how you can tackle this issue. One of the keys, I think, is really attacking the problem from many different perspectives, many different ends. And to that end, you might look at building up from the bottom, infrastructure monitoring, ensuring your logging, security, infrastructure is all running properly, alerting if you have capacity or other outages or warnings, that type of thing. Data pipeline monitoring and ensuring you have notification if the data stops flowing, there's logs getting dropped, errors being encountered, those kinds of things. And then the last piece, the piece that we're going to talk a little more about and where AI can really play a big role, is outage detection. So deploying a model which can understand what's normal, look at understand the trends and determine when you have an outage going on and give you that heads up. And one of the big things outage detection can do is, you can't always plan for everything. There's the unknown unknowns, and that's where, the monitoring on the back end can help you detect when you have problems that your other layers of monitoring haven't caught. So some of the typical outage detection methods are anomaly detection and forecasting, which is a type of time series modeling. And some of the common anomaly detection models, isolation forest is a really popular one, but there's also newer approaches like using deep learning via autoencoders or neural networks, which have shown a lot of success for anomaly detection. Forecasting is another very popular method of determining outages or anomalies, particularly when you have time series data, which is data that has, like there was 10 apples today, there's 9 apples tomorrow, we have 2 apples the next day, we have an outage of apples. Yep, but each approach has its own advantages and disadvantages.
Obviously, there's you're highlighting these two approaches. I'm assuming there's a lot more, and that are maybe other typical ones are not so typical. Is there a reason why we're highlighting these two specifically?
Yeah, the reason I'm highlighting these and particularly wanted to talk about forecasting is one of the biggest strengths of forecasting is one of the biggest challenges with determining outages, particularly with the type of log data you'll see in a cybersecurity context. So we call that seasonality, and that's depicted in this bottom chart here, where you see the days of the week and the impact of the days of the week on our trend of volume. So in this example, we have an uptick on a Monday, and then on a Saturday, that's our lowest time of the week. So that's that's an example of weekly seasonality where, the day of the week has an influence on what we should expect the value that we're trying to predict to be. Some other examples, you can have daily seasonality. So way to think about that, maybe you have all of your users logging on at 9 in the morning, and at 6 in the morning you have few or no users. Does that mean you have an outage at 6? No, it just means, you should expect a lower volume of whatever you're trying to detect on at 6 a.m. And then you also have monthly, annually, and I mean, you could go hourly or down to the minute. You got all kinds of seasonality, and all those can overlay on top of each other. So maybe you have, it's normally a Monday, or it is a Monday, which is normally your busiest day, but now Monday is a holiday, and now it's super low. Again, you might think, oh, hey, we have an outage, but forecasting can combine all that knowledge, and even you can some of the libraries like Prophet, which is a library released by Facebook/Meta that can build forecast models, can even incorporate holidays into their forecast. And then, the model might understand, hey, it's a holiday on Monday. So even though Monday is usually a busy day, we can still say it's less likely to be an anomaly or an outage going on that day. And some big tips I really wanted to give on forecasting, some tricks of the trade, if you will, things that can help you out and really give you a higher fidelity results, and also just things to think about is it's really a big trade-off between how fast you want to be notified and the accuracy of your detection. So the longer, it depends on your type of data, but from what I've seen and experienced with security log data, the sooner you want to be notified, the more lossy you have to be willing to accept of detections, the more likely you're to pick up a false positive, or you think there's an outage and there's really not an outage. But the greater the span of time you're willing to wait. So maybe if you're trying to predict every 15 minutes, right, you're going to see a lot more fluctuation. Maybe some data sets only come in hourly. So then, you're going to see a lot more fluctuation versus if you expand the time range you're trying to predict on to an hour or a day, you'll get a lot higher fidelity. Another trick you can use is looking at the difference between what you expected. So you expected to see 10 apples and you only saw actually observed 2 apples. That's a difference of 8 apples. That's a significant amount versus, you expected 10 apples and you saw 8 apples. There's only a difference of 2, not that significant, maybe not an outage. And that can help you determine from the model's results your confidence and severity of a potential detection. And a few other ones, or I guess one last one. Multiple outliers in a row is another method, and I gotta tip my hat to Mike on that one. But yeah, so maybe you see, you're down on apples for three hours in a row, and then that's another way to ensure, like, hey, we have even more confidence now that we have a problem going on.
Yeah, and one last thing I'm thinking just on forecast. I'm going off script here, Scott, so bear with me real quick. So one of the important things, particularly to say, look, are you in trouble? Right, because there ain't nothing coming in and you might miss something important, is definitely one aspect of forecasting. But building up these muscles around forecasting also can probably help with another aspect of, general health, right, which is capacity. Right, so that if you see that here are my log sources, I'm starting to onboard new log sources, right, that's absolutely going to mess up your current provisioning. And you really want to get a handle on what kind of capacity that you need, because it's not only just the challenge of the SOC to, write detections, tune detections, make sure the detections are running and achieving that integrity, but you're also running infrastructure, right? And most likely you're responsible for running that infrastructure. So health monitoring can really be a 2-for-1 in the sense that you're catching when there are slippages, right? There's issues, there's outages, but there's also the question of, like, what is your capacity planning, right? How do I know that I have enough capacity, enough compute, storage, and network to make sure I can keep up with things, particularly when you say, oh, I'm going to start onboarding FDR logs, right? That's going to test your capacity. And having these kind of tools in place really help you meet the challenge of the volume.
Point, yeah, for sure. So this might look familiar. How do you approach it? How do we approach it? Well, the fundamentals are there. So we have infrastructure monitoring in place, data pipeline monitoring, and outage detection. And really, you can think about this as defense in depth. So we have multiple layers of monitoring, and there's a lot of overlap. And you might say, well, why do you have overlap? That's extra work. Well, it's good to have that overlap because maybe one of the detections stops working, maybe it misses it for whatever reason. It wasn't an expected error type to occur, and that's caught in another layer. So that's really our approach, and we have all these layers deployed in, and use them. Yep.
So let me ask you a question, Scott. I'm just thinking out loud. So where is the best place to actually, that pane of glass for monitoring? I'm just curious, because I have my preference, but I think you'll probably grimace. But I mean, where should this, all your events, all your alerts really be going to?
So you mean like what system do you want to look at your logs in?
Or that single pane of glass where you can kind of look at everything aggregate.
Yeah, I mean, I'm not too particular on where it is, but I think the key for me is it all needs to be in one place. A lot of times it's not in one place, and that can be a huge, so that's what I would say. What about you?
I was going to say Slack. I don't know if people on this call out there in our audience use Slack. It's tough, right? Because I got to tell Scott something important, right? I want to see how his weekend was, right? But then I see a health monitoring alert. It's right there. We can act on it. So you bring up a great point. Really having that single pane of glass, right? That you can just go to. You don't want to oversubscribe your Slack. Have some sort of poverty of the commons situation. But it is helpful to send tidbits there, because that whatever your communication platform is, be it Slack or Teams, maybe email, maybe not email, but basically it gets somewhere where that someone will bump into it. I know that from personal experience, like I had pager duty, might have accidentally left the pager in the wrong room, right? Missed the alerts. But yeah, definitely I'm not going to miss something on a social platform.
I'm almost thinking maybe this could be part 4 of just what is the best way or templatizing ways to escalate the information. I know at my house, I call him Mr. Duty goes off all the time at all hours, and we're having to call in and put, from both my husband and I, where we're having to say, no, not a big deal, decline it, send it to someone else to triage. But it's like, why are there all these different steps to get to the most important thing? And yeah, it's going to be needed, but what is the best way? Is it Slack? Is it like, how do you determine what's going over Slack versus what's getting pinged over a PagerDuty or something? Or what are some of these tools that we can use? So I don't know. I'm thinking maybe a part 4, just really get down to brass tacks on best practices.
Exactly. And like, what if your team's geographically distributed, right? There's a lot of complications, right? So
Someone's on vacation.
yeah, because occasionally we have to, right?
For sure, yeah. And I would say too, severity, you can, like I mentioned, you can look at how far the value you observed versus what you expected. Maybe the severity drives some of where it is routed. So if it's severe enough, it does blow up your Slack. And if it's not, maybe, that kind of thing. But yeah, one
But
of the
this is,
th oh,
nope, keep going, Scott.
no, go ahead.
Hope you're going to say one of the things. I want to hear what one of those things are.
Okay. All right. Yeah, so on the outage detection piece, one of the things I wanted to call out because I think it's really cool is, that's kind of one of the last layers of defense. And one of the things it's looking for is some of those unknown unknowns that cause, an outage or a problem that, we can find on the back end. And through some of those detections, we've even been able to find issues upstream of our system. So that kind of goes into our next slide, but issues where, maybe a customer had some parsing problems or their log stopped flowing and then they stopped coming into us. And we were able to go tell them, hey, we've found this problem on your system. You want to take a look at it.
Before jumping into kind of the next piece of this, I just kind of want to bring this full circle. We talked about at the beginning how important health monitoring is. I think everyone kind of knows it. It's not the sexiest topic to talk about. It's one of those things that you just have to get done, like we've been saying. But instead of just saying, yeah, it's important, this is how you do it, I think how you're framing this of being able to create these triggers and almost make this mundane thing that's just a annoying thing to have to do, something that's actually informing you. And I think maybe that's the separation that I'm hearing is we need to get people to, or we all need to get to this place where the health monitoring becomes that trigger for creating the insights, for prescribing everything else you're doing, because without understanding what's going on in your environment, you're not able to build the right detections. You're not able to do all of these other things that come before it. And so on the output of the health monitoring, you're not going to get the amount of information and insights that actually can feed back into that loop. So I guess maybe we could talk about a little bit, like how do we get there? What is that there to make sure that health monitoring becomes the forefront of people's mind, and that it can be maybe it will never be sexy, right? But the true benefit of doing this correctly and getting your health monitoring to a place that can inform decisions.
Yeah, I think that's a tough question, but I would say definitely a tough question. That's
That's
what
all
I
right.
would say.
I'm here to ask the tough questions. No, I think that it's a tough question because people haven't been solving for this. It has just been something that we're like, as you've discussed, like this is how you can start forecasting, doing these detections, right? That how you can start feeding back in and using the health monitoring to your benefit. So I guess maybe I'll frame the question slightly differently. Maybe it's the wrong question to be asking, right? Maybe the question to be asking is, what is the output from health monitoring that people want to know the most?
Ooh,
They can inform back.
Yeah, I would say that. Yeah. So, it is tough. Health monitoring is like brushing your teeth, right? No one's like, oh man, I woke up. I can't wait to brush my teeth 3 times today, right? If I even get to 3. But no, the big thing here is like, I think probably number one, the most paramount thing is like, hey, did everything that I needed to run actually run? But like, I think going beyond that, right? One question is if you are looking at the trends in your monitoring, right? And there are troubling trends, right? Like you have people who are spending a lot of time triaging, remediating, hardware and data pipeline issues, right? Then you really got to ask yourself as a leader in that organization, right? Is that like, not just like, hey, do I have the right people doing the right job, right? But do they have the right tools to be doing the right job, right? So there's a lot of like, when you talk about data pipelines, right, you can probably name right off the bat several different types of pipelines that you can, outsource from the cloud, run from your own, right? And you really got to ask like, hey, if I have this setup and this setup is causing a lot of issues internally, right? That people are spending a lot of time trying to triage and fix, the infrastructure, fix the pipeline. So as a leader in that organization, I'd ask like, that's not what people want to do, right? When you have outages, when you have to fix infrastructure, you have to like deal with software issues in your pipeline. That's stressful, right? That's not fun, right? That's a great way to burn people out, right? So I think that, health monitoring can really actually help you make good decisions about, what is your setup? How are things going? Am I using the right tools, the right platforms, right? When can I, manage, third parties, right? To potentially, make my, employees' lives a little bit easier. Maybe the trade-off is, price or cost, or is it something that maybe, something that is custom is working really well for us and we should continue on that path, right? So I think it could be really interesting to go beyond just like, hey, do I have a problem? Are my searches, my correlation searches are not running, to a question about like, what is the performance of the infrastructure in my SOC, right? And, it could be a very, health monitoring could be a good proxy to measure like, am I burning people out because they're spending too much time responding to things versus, really building and understanding that are we in a good position, that we're really focused on understanding our, attack surface versus like, wait, did my NiFi cluster go down?
Yeah, great answer.
Awesome. Yeah, so we'll look at the next slide a little more on how we provide you, the customer, health insights in our product. So maybe you have your data flowing in from on-prem, you can leave it where it is and we'll use it, or it's coming in from a vendor alert, we'll integrate with them and bring it in. So we have, like we went through those 3 layers, we have health monitoring on the infrastructure, on the data pipelines, and outage detection applied to all of those. And particularly want to hone in on the AI Insights tab, which we will provide health alerts where we might say, for example, hey, we noticed you have this detection that detects desktop image downloader running, downloading files. And for whatever reason, it's failed to run 10 times in the last 12 hours. So we'll provide a reason that it's, that we've seen. Maybe we saw an error message like your CPU utilization was too high or something along those lines, and also recommended actions for how to reestablish that detection. Cool. And then the last thing we got is a little takeaway, some checklists to go through and things to look at there.
So you can go for it.
Yeah, I wanted to talk about just 1 or 2 of these that I think are super critical. I mean, all of them are super important, but we mentioned asset inventory. Really can't protect what you're not aware of. Look for hosts that are not logging, or you can kind of take a threat hunting approach and look in your logs and try to find hosts that you're not aware of. Different ways you can attack that, but super critical one. And also, again, on the command line parameters, I'll beat the dead horse again on that one because super important to have that visibility.
Yeah. And then, let me throw in mine. So I would say for me, top of mind, those are good ones. And as Scott said, like they're all good, but like parsing errors. So do me a favor, right? You write a macro that can be or update a macro that can be the easiest way to just cause all sorts of failures and issues in your environment, right? So writing that macro is super important. But look, you write a macro, it makes mistakes, you parse things incorrectly. So one of the things I would recommend is, for me, because I'm a nerd, I do machine learning the day is long, right? I have, machine learning models and I try to predict, does this look like a correct username or not? And that's pretty good, but you don't have to get that fancy, right? I would say that occasionally, if you search, you say, look, do a group by distinct of usernames and just, randomly select 10, 50 of them and just take a visual look. Sometimes the most egregious errors that I've seen will manifest in just a small sample, right? So you just need a small sample, group by distinct, username, look at, a random sample, and you should be good to go. So, but yeah, definitely, malformat, incorrect macro can just ruin your day, and it will cause these parsing errors, make it super difficult to do any kind of correlation search, particularly when you actually have an incident. You need to start pivoting on user or host or what have you.
And nothing worse than finding an interesting security log and then the parsing isn't there.
Exactly.
Scott, Mike, any final thoughts on health monitoring and AI? What do you want to leave everyone with? What's the full round picture of why should, I know we talked about why, how, but really, what do we leave people with here?
Yeah, I'd say my key is really, you need to take a defense in-depth approach. And that's a cybersecurity term for having multiple layers of detections, multiple layers of coverage, protecting the same thing. And that's really going to be your only path to success. If you only have one layer of coverage, one layer of detections, you're just going to miss things, and it's just what happens. And you need to have multiple layers to really have an effective health monitoring program.
Exactly. And in each of those layers, wherever you can, right, if you can use AI, machine learning, I mean, even statistics, right, to help, minimize the number of things that you have to look at in each layer for potential outages or errors or other complications. I think that's the critical bit. And absolutely, as JD were saying earlier, computers do an excellent job of recognizing patterns. So let the computer do what it's good at, that can do 24/7 and really just understand your data, understand the flows, and then you can really kind of diagnose the trivial, so the non-trivial, the sort of actual bugs in your system, and then act on that. So ML can be a great tool to filter down to things that you need to know about what issues might exist in your environment.
Yeah, let's make your life easier with the ML, AI, all this stuff. But at the end of the day, if it doesn't have the right information, you're not asking it the right questions, you're not giving it the right anything, it's not going to give you what you need.
That's right. You're going to have a bad time.
A bad time. All right. Well, thank you all for joining next week. Please, not next week, but the following. Please join us for our detection dispatch that is detecting lateral movement in Microsoft Windows. So we'll be going into a lot of different areas of detecting lateral movement, how to make that easier, get into some specific examples. So definitely make sure to join us for that one. I just want to thank Scott and Mike again for joining us, lending us your brains from a data science and security perspective. And I think we'll be talking about part 4 soon as well, on getting down to the brass tacks of how to implement all this. So thank you all again, and I will be seeing you in a couple weeks.